Have you ever wondered about that? I mean, think about it. Those little camphor balls you see in temples, or maybe mothballs tucked away in a closet, they just shrink and vanish over time, right? There's no puddle, no sticky mess, they're just gone. Or what about dry ice, that cool, smoky fog it makes? It's not melting, so what's the deal?
Well, that whole vanishing act, it's not magic. Nope. It's actually a super cool scientific process, and that's what we're going to break down today. The process is called sublimation, and believe it or not, it's happening all around you.
So, how does it all work? Well, let's talk about the sublimation shortcut. You see, most stuff follows a pretty predictable path when it changes from one state to another. But sublimation, it's different. You can almost think of it like a special VIP shortcut that only certain materials get to use. Okay, so here's the official definition. Sublimation is when a solid turns directly into a gas. And the key thing here, the part you've got to remember, is that it completely skips the liquid phase. Poof! Straight from solid to gas. No melting, none of that. Just to make this super clear, let's compare the normal path versus the shortcut. Normally, right, things take the scenic route. Think of an ice cube. It has to melt into liquid water, then you have to boil that water to get steam. Solid, then liquid, then gas. But sublimation? Nah, it's a direct flight. It's that express lane, going straight from solid to gas. Way quicker and way cleaner. All right, so this begs the question, right? Why do only some solids get to take this special shortcut? What's the science behind this quick change? What makes them so special? Well, simply put, some solids just like to break the rules. Seriously, you can think of them as the rebels of the molecular world. While most materials are patiently following the rules, waiting to melt, these guys, their particles are just way too restless. They've got so much energy they just can't wait. They break free and jump directly into being a gas. And it all boils down to one key scientific idea. And that idea is something called vapor pressure. So here's an easy way to think about it. Imagine every solid is a crowded room. In most solids, the people, the particles, are kind of stuck together, held in place. But in the solids that sublimate, the particles are already buzzing with energy. They're antsy, barely holding on. They're so eager to get out of that crowded room that they can just leap straight out the door into the open air, which is the gas phase, without having to slowly shuffle through the liquid hallway first. Okay, I know this might sound like some obscure thing that only happens in a science lab, but I promise you've seen this in action. Let's talk about some real-life examples, because this stuff is literally everywhere. Example number 1, camphor. You know that strong, very distinct smell you get in temples or maybe from some old-school room fresheners? Well, that powerful scent, that is the camphor sublimating. Those are its particles escaping directly into the air as a gas. And that's exactly why the little solid block just gets smaller and smaller and eventually disappears, leaving zero mess behind. And hey, the very same thing is what protects your favorite wool sweaters. Mothballs. They're made of something called naphthalene, and they work by slowly releasing a gas that bugs hate. And where does that gas come from? You guessed it. It's coming directly from the solid ball as it sublimates over months. That's why they just vanish after a while, once their job is done. Now, for probably the most famous, most dramatic example of all, dry ice. That awesome, spooky, rolling fog you see in movies or at a rock concert, that's not smoke, not at all. It's actually solid carbon dioxide, and because it's so incredibly cold, it just turns straight into a gas as it warms up. That's sublimation, putting on a show, creating the ultimate special effect. And if you want a really, really stunning visual, you have to see what iodine crystals do. When you heat them up just a little bit, they don't melt into a puddle. Nope, they completely skip that and just erupt into this incredible, vibrant cloud of purple vapor. It is the perfect, most beautiful demonstration of sublimation you could ask for. All right, that was a whirlwind tour of some pretty cool science and a bunch of examples. So let's pull it all together. Here's your quick sublimation cheat sheet to make sure you've got this down. So the core process, what is it? It's so simple. Step 1, you start with a solid. Step 2, you completely skip the liquid phase. And step 3, you end up as a gas. That jump, that skip from solid to gas, that is the absolute heart of sublimation. Okay, let's lock this in. So, to recap, what is it? Solid to gas directly. The big examples to remember, camphor, naphthalene, dry ice, and iodine. And where do we see it used? All over the place. Mothballs, room fresheners, cool stage effects, and even for purifying things in a lab. And that takes us right back to our original question. That mysterious disappearing act? It's not a mystery anymore, is it? It's not magic. It's just some really cool fundamental physics at play. It's sublimation, and now you know exactly what's going on. So let's end on this thought. Sublimation is a perfect reminder that things that seem like magic at first, well, they usually have a perfectly logical scientific explanation behind them. So what other little bits of everyday magic have you seen? Chances are it's just more amazing science waiting for you to figure it out. Keep asking questions and stay curious.